our objectives to be able to, number one, generate and describe a pattern. Number two, find the next few terms of the sequence. And number three, find the general or nth term of the sequence. And before we would proceed to our discussion, let us know first the definition of what is a pattern and what is a sequence. Okay, so now let's have a simple definition. So a pattern, it generally establishes a common relationship between all numbers or objects. And a sequence is a chain of numbers or other objects that usually follow a particular pattern. Now, let's have an example so that we would easily understand what is the difference between a pattern and a sequence. Okay, let's use this illustration so that we would understand better what are the difference between pattern and sequence. Okay, now so let's have objects, and our objects would be boxes. Okay, so on the first one, we would have two boxes. There are two boxes that you could see, and then let's add another picture, and then those would be consisting of four boxes. So on the first picture, we could see there are two boxes, and on the second picture, we could see that there are four boxes. Then let's add another one. Let's say there would be, let's say 1, 2, 3, 4, and 6. This time we have 6 boxes. Okay, and by definition, when we say pattern, it is generally establishes a common relationship between all numbers or objects. So let's add that, all numbers or objects. Now, what's the relationship? All of them are boxes. Yes, that's one observation why we could consider it as a pattern. All of them are boxes. And what else? On the first image picture that we have two boxes. And on this one, we have 4. And on the third one, we have 6 boxes. So based on that observation, we could say that in every picture, there's an additional box. There's an additional boxes. And how many additional boxes that we are having? And that would be 2, right? So from 2, we added from 2 boxes. So we added, let's say, from 2 boxes, we added it by 2. And therefore, there are 4. And then on the 4 boxes, we then again add another 2. So that's why there are 6 boxes. And that relationship that we just observed is what we call the pattern. Okay? So meaning, those that we observe the relationship where in every picture there are 2 boxes that are being added, that is what we call the pattern. Okay, so in this case there are 2 boxes, and then we would add another one. There are 4 boxes, and then we would add another, and there are 6 boxes. Okay, and that observation that we have, let's say they are boxes, and in every picture there are additional 2 boxes, and that is what we call the pattern, the common relationship of the object that we just observed, and that is a pattern. Okay, and when we say sequence, okay, as one, okay, when you say sequence, they are treated as one. Okay, as one, these boxes are considered as a sequence. Okay, as one, they are considered as a sequence. We could say that this is a sequence of boxes, wherein we could say it is a chain of numbers of other objects that usually follow a particular pattern. And that particular pattern that it follows is that there is an additional of 2 boxes in every next picture. And that is the difference when we say pattern and sequence. And let us continue with our definition. So as you can see on our second objective and our third objective, we mentioned the word term. Okay, so we mentioned the word term, and that is why we need to define it first so that we would know what are terms. Okay, and by definition, when we say term, terms are individual elements in a sequence. Okay, again, they are individual elements in a sequence. As we could see, these boxes as one, we considered it as a sequence. It is a sequence of boxes, and the individual elements is what we call the terms. So therefore, this one is considered as a term. This one is another term, and as well as this one is another term. And basically, if it is on the first object, the first one, and it is called our first term. Okay, it is called as our first term. So this is our, so let's change the color. This is our first term, and of course you could also have its symbol. Okay, so that is the first term, and then this one is our second term. And wait a bit, in a moment. Second term, and we have third term. Okay, so the first set of objects is what we call the first term, the second set of objects is what we call the second term, and the third set of objects is what we call the third term. Okay, first term, second term, and third term. And we also have the symbols for it, the symbols. So for the symbol of the first term, it would be like this. Symbol for first term, that would be a sub 1 for the first term. For the second term, that would be a sub 2. And for the third term, the symbol would be a sub 3. Okay, so it's very important for us to get acquainted with the symbols, because later on our discussion and further discussions, we would always use the symbol. So a sub 1 refers to the first term, a sub 2 refers to the second term, and a sub 3 refers to the third term. Okay, and now let us proceed to our first objective: generate and describe a pattern. Okay, to be able to generate and describe a pattern. So now, what if I would ask you a questions like this: what is the next term? Okay, so we have the first term, we have the second term, we have the third term, and you are asked, what do you think is our fourth term? So what is the next term? And we would observe, of course, we would go back to pattern. We would look into the pattern so that we can identify what is the fourth term. Okay, so based on our earlier discussion, the pattern here would be 2 boxes, 4 boxes, 6 boxes. There is an additional of 2 boxes in every next terms, right? So definitely we could say on the fourth term, we would have how many boxes? Okay, we would have 8 boxes. Okay, so it's why 8 boxes? It's because of the pattern that we had earlier. And we said earlier that in the first term we have 2 boxes, and the second term there are 4 boxes, wherein there are 2 additional boxes in every next terms, and that is why on the fourth term there would be 8 boxes. Okay, so we would have 8 for the fourth term. And how about for the fifth term? So first term 2, second term 4, third term 6, fourth term 8, and the fifth term definitely we could say that there are 10 boxes, and so on, right? 10 for the fifth term. For the sixth term, that would be 12. For the seventh term, that would be 14. For the 8th term, that would be 16, and so on. As long as we know the pattern, and the pattern is that we would just simply add 2 for the next terms. And now, let us continue our discussion. And just a reminder, when we say sequence, it does not limit to objects. The one that we use here are boxes. When we say sequence, it could be any other objects, and as well as it could be also a chain of numbers. Okay, so now let's have an example wherein our sequence would be a chain of numbers. Okay, so let's have this one. So let's have our example. Generate the pattern that describes the sequence and identify the next terms. Okay, so how to generate the pattern? Okay, that's the question. How to generate the pattern? And basically, for us to generate the pattern, we must do the observation. We must observe one by one each and every term so that we would know what is the pattern. Okay, first, the one that we would do is observe. Let's go with number 1. Let's observe the sequence, every terms in the sequence, so that we could generate the pattern and then we could identify the next terms. Okay, so let's have the observation now. The first one is we have 2, and then we have 4, we have 6, we have 8, and we have 10. So let's look into the terms. 2, 4, 6, 8, 10. And then what could we observe on that? We could observe that on the first term there was 2, on the second term there was 4, on the third term there was 6, and then 8, and then 10. It's almost the same with our example right here. So therefore we could say, what would be the next terms? After 10 would be 12, right? And after 12 we could have 14. We just simply, based on our observation, we could say that on sequence number 1, the pattern is that we would just simply add 2 on the next following term. So we say 2 plus 2, we have 4, plus 2, we have 6, plus 2, we have 8, plus 2, we have 10, plus 2, we have 12, and so on. So we have 14 plus 2, we have 16, 16 plus 2, we have 18, and 18 plus 2, we have 20. Okay, so it's very important for us to have our observation. It's crucial. Okay, if we have a good observation of the pattern, then we could easily fill in the missing or the next terms. Okay, so let's continue. Let's continue on sequence number 2. So we started on 17, 19, 21, 23, 25. So the first term is 17, the second term 19, and so on. And let us observe it then again. And then we could say, we then again added 2, right? We added 2. 17 plus 2, 19, plus 2, 21, plus 2, 23, plus 2, 25, and then 25 plus 2, that would be 27. Plus 2, that would be 29, plus 2, 31, plus 2, 33, plus 2, 35. Okay, very easy. How about number 3, the third sequence? The first term we have 48, the second term we have 44, then we have 40, we have 36, we have 32, and what could we observe on that one? What could we observe? We just simply added what? Did we add something? Yes, we add something, and we added negative 4. So 48 plus negative 4, that's 44. 44 plus negative 4, that's 40. 40 plus negative 4, that's 36. Or we could say we just subtracted 4, right? So let's continue this one. So 32 plus negative 4 or minus 4, we could say that would be 28. And then 28 minus 4, that would be 24. Minus 4, that would be 20. Minus 4, that would be 16. minus 4, that would be 12. And then the next one, we have sequence number 4. We have 10, 15, 20, 25, 30. So let's observe the sequence. And then we could say that the pattern is we simply added 5, right? We added 5 on the next next term. So we could say 10, 15, 20, 25, 30, and the next one would be 35 plus 5, that would be 40, plus 5, that would be 45, that would be 50, and that would be 55. Okay, and how about for the last, number 5, last sequence? We have 27, 25, 23, 21, 19. The first term is 27, followed by 25. So we could say, based on our observation, we simply added negative 2, right? We added negative 2, or we subtracted 2. So this would become 27 minus 2, 25, minus 2, 23, minus 2, 21, minus 2, 19, minus 2, that would be 17. And then 17 minus 2, that would be 15. 15 minus 2, that would be 13. 13 minus 2, 11. And 11 minus 2, that would be 9. Okay, those are our examples wherein we are using chain of numbers as our sequence, and in order for us to identify the next terms, we use the pattern that was based on our observation, and that is why we were able to identify the next terms. Now let's focus on our first example, our first sequence. As you could see, our first example, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There are only 10 terms, so we're in 2 is the first term and 20 is the 10th term. Now, as you could see, our first example, our first sequence is limited to 10 terms. That is why it could be also called as a finite sequence. Now, there are cases you would see sequences that looks like this. We have 2, 4, 6, 8, 10, and we have 3 dots. The 3 dots there are called the ellipses. And in this case, this 3 dots means it would go beyond, it would extend towards the infinity, towards, in this case, towards the positive infinity. And that is why cases like this, they are called the infinite sequence. Okay, so now we have the finite sequence and the infinite sequence. Okay, to remember them, so when we say finite sequence, they are limited, it has an ending. And when we say infinite sequence, it starts with a term and it goes beyond to the infinity, and it would never stop. That's why it is infinite, and that is infinite sequence. So now let's go to our infinite sequence. Now, for example, we have the same example, 2, 4, 6, 8, 10. As we could see, 2 here is our first term, 4 is our second term, 6 is our third term, 8 is our fourth term, and 10 is our fifth term. And it goes beyond to the specific term that we are finding. Now, on this case, it is very easy for us to find its next few terms. For example, you would be asked, what is the, let us say, you would be asked, what is the 7th term? Or let's say, what is the 12th term? For example, what is the 12th term in this case? So the 12th term would be 24, right? So you could do the manual. You say 10, the 6 would be 12, 14, 16, 18, 20. Just the same with this. Then after 20 would be 22, and the 12th term would be 24. Okay, and if you would be asked, what is the 13th term? Let's say the 13th, that would be 26. It's very easy, right? But if you would be asked, for example, what is the, let's say, 87th term? Okay, what is the 87th term? And that is another question, right? Because it is quite impractical if you do the manual. Let's say 2 plus 2 plus 2 plus 2, depending on the pattern, based on the pattern. That is why it is necessary for us to derive a mathematical rule based on the pattern of our sequence. On this case, our mathematical rule would be a sub n, meaning it refers to the term that we are finding, is equal to 2n. 2n is our mathematical rule. Now, so let us check 2n. Okay, now this, let's fill in this corner. So a sub n, if you could see here in this case, a sub n, it refers to the specific term that we are finding. Okay, the specific term that we are finding, and we would have, okay, for example, let's have the first term, let's have the second term, and then we have the third term, the fourth term, the fifth, okay, the sixth term, the seventh, okay, we have the eighth, and we have the ninth term, and we have the 10th term. Okay, so these are for the terms that we are about to find: the first term, second term, third, fourth, fifth, 6, 7, 8, 9, and 10. N refers here to the order of terms. What term is it? Okay, so for a sub 1, or the first term, that would be 1. For the second term, that would be 2. The third term, that would be 3. The fourth, okay, and so on. And then afterwards, let us check and find its value of the term using our mathematical rule. And this would be 9, and this would be 10. Okay, so now let's use our mathematical rule. We have a sub n, or the specific term that we are finding, is equal to 2n. So we have 2 here as the constant one, so 2 times n, n is here. So for the first term, 2 times 1, that would be 2. For the second term, we have 2 times n, that's 2. 2 times 2, that's 4. How about here? 2 times n, and n is 3, that would be 6. And so on. Let's have 2 times 4, that would be 8. And then here, that would be 2 times 5, that would be 10. And here, this 2 times 6, that would be 12. Let's have 2 times 7, that's 14. 2 times 8, that's 16. 2 times 9, that's 18. And 2 times 10, that's 20. Now, let's answer the question. This question: what is the 87th term? Now, what is the 87th term? We would find the 87th term using this one. Since a sub n, our specific term, is equal to 2n, so we could have the 87th term is equal to 2n, right? 2n is equal to 2n. Now, that is 87 is equal to 2n. And then let's find for it. Okay, the 87th term is equal to 2 times n. Here refers to what term are we finding. So that's to be multiplied by 87. So that would be 2 times 87. We would have 2 times 87. That would be 160. 2 times 80, 160. 2 times 7, that's 14. 160 plus 14, that would be 174. Okay, so our 87th term, based on our sequence using our mathematical rule, which is 2n, that would be 174. That is for us to find the specific term using the mathematical rule without doing the manual. It's because it would be quite impractical. For example, we would find for the 87th term, and you would do like the same like that we did earlier. We were adding, let's say 2 plus 2 plus 2 plus 2 plus 2 until 87 times, and it is quite impractical even if you would use your calculator. That is why it is necessary for us to formulate, to derive our mathematical rule so that we could directly find for the missing term or the term that we wanted to find out. For example, let's have another example. You are asked what is the, let's say, 315th term. What is the 315th term? So, based on our pattern and our mathematical rule, in order for us to get the 315th term, that would be is equal to 2n. So, that would be like this, 2 times 315, right? And then, the 315th term would be, okay, 2 times 315, that would be 600. 15 times 2, that would be 630. Okay, as easy as that. If we have our mathematical rule, and then it's very easy for us to find for the next following terms that we wanted to find. This is an intro in order for us to proceed on the arithmetic sequence and the geometric sequence and all of the other sequences. It's because we are finding for the specific terms of those sequences. That is why it is important for us to know how to find or how to make the mathematical rule. And let's use this concept. Don't you know that mathematical rules could also generate sequences? Okay, let's try. Let's generate a sequence using the mathematical rule. Now, for example, let's have this mathematical rule is equal to, let's say, let's say say this one, 3n plus okay, 3n minus 1. For example, that one, 3n minus 1. Now, how would we generate, okay, using this mathematical rule, how would we generate terms? Okay, how would we generate terms? As easy as doing like this. The same with this one. So now, let's try to find the first 5 terms, okay? Let's try to find the first 5 terms. So, let's have this first 5 terms that A is equal to, let's say, 3n minus 1. Okay, let's use this, 3n minus 1. Okay, let's have it as 24. And then let's put it here. Okay, let's do this first for a moment. The outline would be no outline. Okay, so let's use this one. The specific term, or a sub n, is equal to 3n minus 1. Let's use this concept in order for us, or let's use this mathematical rule in order for us to generate. Okay, let's generate a pattern. Okay, so the same with this one, the same with the early example. Let's find for the first 5. So first five terms. So a sub 1, a sub 2, first term, second term, third term, and the fourth term, and the fifth term. Okay, so let's use this one in order for us to find the first 5 terms. Okay, so let's whiten this first. Okay. Okay, now let's try. So we would have, okay, let's use red, n. Okay, n for the first term, that would be 1. For the second term, that would be 2. For the third term, that would be 3. For the fourth term, that would be 4. And for the fifth term, that would be 5. Let's use our mathematical rule in generating the first 5 terms on this sequence. Okay, so let's try to substitute. So the first one would be, the specific term is equal to 3n minus 1. For the first term, n would be equal to 1. So 3 times 1, that would be 3 minus 1, that would be 2. And for the next term, so n would be 2, 3 times 2, that would be 6, minus 1, that would be 5. And then n would be 3, 3 times 3, that would be 9, minus 1, and 8. And for fourth term, that would be, the n would be equal to 4. So 3 times 4, that's 12, minus 1, and it's 11. And for the fifth term, that would be 5. So that would be 3 times 5, 15, minus 1, and it is equal to 14. Okay, and it's equal to 14. Now, that is how we would find for the, or how would we generate terms using our mathematical rule. Now, for example, let's then again use our mathematical rule. What if you would be asked, what is the 37th? Okay, what is the, wait a bit. What is the 37th term? Okay, what if we would find the 37th term? It's the same with what we did earlier and how we did generate the terms. We would just simply substitute n for the specific term, and that would be equal to 37. So now that would be the specific term, or the 37th term, is equal to, that would be 37. So 3 times 37 minus 1. Okay, that would be 3 times 37 minus 1. So our 37th term would be equal to 3 times 37. That would be 30 times 3, 90. 3 times 7, 21. 90 plus 21, that's 111 minus 1. And our 37th term is equal to 110. Okay, so it's just the same. The application of our mathematical rule is it could generate, our mathematical rule, it could generate the first 5 terms or the first 10 terms, and it could also find a specific term that we are finding, especially those terms that are way farther, okay, than the first term. Now, let's have another example. For example, you are asked to find, let's say, another example, what is the 52nd? Okay, what's the 52nd term? The process would be still the same, is that you would substitute and you would utilize the mathematical rule, wherein n would be changed or substituted. The value of it would be the number of terms that you are finding. In this case, that would be 52. So that would be 3 times 52 minus 1. So the 52nd term would be equal to 3 times 52, that is 50 plus 10, that's, no, 50 plus 6, that would be 156. Okay, okay, so 156 minus 1, and our 52nd term would be equal to 155. Okay, so this example wherein we have our mathematical rule, based on our given example, we generated the terms, and we find some specific terms. Okay, so that is why it is very important for us to generate a simple, or rather than derive a mathematical rule based on the pattern of our sequence, so that we could find terms that are way much farther. For example, like this, the 3/15th term. So that is how important for us to derive a mathematical rule based on the pattern of our sequence. So I guess that would be all for today. So you may comment down below if you have further questions, and I am glad, and then I would like to answer those questions. Okay, so I guess this would be all for grade 10 week 1, and God bless you all.